clash of ideas. The Alps, geology, and scientific revolutions.
The surface of the Earth is very uneven, with high mountains like these standing thousands of meters above sea level and low places on the deep ocean floor. This is why scientific wisdom once excluded the possibility of finding in the middle of mountains rocks that had formed on the oceanic floor. This long-held and common-sense assumption was challenged by an enigmatic type of dark rocks found throughout the Alps, like these ones in Switzerland. These rocks helped to build the case for the greatest scientific revolution in the history of geology: plate tectonics.
Episode 4: A Lost Ocean and Plate Tectonics. In 1813, French geologist Alexandre Brongniart coined a new name for a suite of dark rocks, calling them ophiolite. This name came from the Greek words for snake and rock, which seemed fitting for these smooth, dark green rocks vaguely reminiscent of snakeskin.
European geologists were relatively well acquainted with these dark rocks that were found in several parts of the Alps and the Apennines. However, in the early 1900s, the German geologist Gustav Steinmann, while studying ophiolites, arrived at a revolutionary conclusion. He noticed that ophiolites were consistently associated with layered strata made of limestone and chert, a silica-rich rock.
Sediments of similar composition, consisting of lime and silica ooze, had been retrieved from the deep sea floor. Steinmann was aware of this, and he became convinced that the ophiolites, along with associated cherts and limestones, must have formed on the deep ocean floor.
If this was true, however, what were rocks made from deep oceanic sediments doing several kilometers above sea level in the middle of the Alps? This was puzzling because at the time, continents and oceans were thought to have remained in the same position since antiquity.
At the most, it was believed only continents' edges could fold to form mountains and depressions. No one could think of a possible way to uplift deep water oceanic rocks into mountains. It would take about 40 years to provide a satisfactory answer to this riddle. In the 1960s, a wealth of new information from the oceanic floors and the study of earthquakes revealed that in the Earth's past, oceans had been dynamically created and destroyed. It was discovered that the Earth's crust was divided into pieces called plates that had moved around, crashing into each other. These collisions buckled the plates, forming mountains, and sometimes pushed up slivers of oceanic crust that were trapped between colliding plates.
And there lay the answer to Steinmann's riddle. Ophiolites were nothing less than remnants of lost oceans trapped in a giant collision of continents. It is astonishing to realize that the ophiolites found among these mighty peaks originally formed well below sea level. These rocks are tangible evidence of mighty forces that have been unleashed in the past. In the pages of Scripture, we find an account of God using His power to organize and rearrange the earth's surface at the creation and at the flood. In Romans 1:20, we are told,
"Ever since the creation of the world, God's eternal power and divine nature, invisible though they are, have been understood and seen through the things He has made."
For me, the gigantic plate motions revealed by ophiolites generate a sense of reverence and awe. They allow us to catch a glimpse of the divine hand powerfully at work throughout the history of our planet.